So we're going to look at the Oxidation Reduction Activity Series Lab. This one's kind of neat because you kind of can feel like a chemist in a little bit of a way because you're actually doing some little experiments. You'll see some things react and some things not react. It's all very small scale, so you don't have to worry about having a lot to clean up at the end. If we look through the exploration section, you're going to learn or see a reminder about chemical reactions. Now, you've already learned about chemical reactions. You've already learned about the plus side. You learned this is reactants, that's the products, and you've learned how to balance them. Now, there's a whole section about oxidation numbers, and hopefully you've also reviewed the oxidation numbers. You kind of remember how to do those. Most of the time on the quizzes, you will be given oxidation numbers, or you won't need them, though. So this is just for this lab, and it's very good practice for this lab. It will also help for Gen Chem too. And here's oxidation and reduction. So when you see, notice there's a blue thing on the left, and it is becoming positive. It's going up. So that's oxidation, is when that number's increasing. I like to remember that because the X looks kind of like a positive sign. And reduction, it's when the number is going down. So right here, that 0 is going to a -1. Now, oxidation is loss. When you become positive, it's because you are losing electrons. When you become negative, it's because you are gaining electrons. So that's where this little mnemonic comes from. Remember, if you determine that something is an oxidation, you have to flip the word when you're talking about the agent. It becomes reducing agent. Okay, so there's just some information about that, and you just have to identify which is the oxidation and which is the reduction. This is a little bit about assigning oxidation numbers. So you can just practice. It's just like a list of rules is what it is. They do theirs a little differently than we talk about them, so whichever way resonates with you is the way that will work just fine. And then redox just means it's an oxidation reduction, and it means you can't have just one going positive and that's it. Like if one goes positive, then something else has to go negative or go down. See, so the red has to go down if the blue's going up. That's a redox reaction. So that's what we're going to see today. You're going to see something that looks like a chunk of metal, and then it's going to end up looking like it's liquid with color or dissolved or something like that. That's what you're looking for. You definitely want to have a white paper under your little well plate you're going to use so that you can see the colors. Sometimes they're very, very faint because these are such small quantities. And here's just some help on reminding you the oxidation, the increasing activity, and how good it is at oxidizing. This might be helpful information for one of the questions. All right, so experiment materials. I do recommend a nail file or sandpaper or something. There's one reaction where it's hard to see, and if you're not getting a reaction, most likely it's because you didn't file it. Scissors, this is just a cut. There's like some little strips of metal, so you're just going to cut the metal in half. Pencil, paper. You do want the paper towels because you're going to be kind of having, like whatever you clean up, you're just going to wipe it up with paper towels. This has metals in it, and you just want to be careful. I mean, it's iron, right? Or lead, but we just have to be careful with some of these metals with our bodies. And so just make sure that you're wearing your gloves, you use the paper towels, and you wipe up everything really good at the end. This isn't the kind of lab where you do part of it one day and part of the other. You'll get it all done in one swoop. Stopwatch, timer, or watch, your cell phone timer is fine. And it's just because you wait 30 minutes in the middle of it. And there's all the material you need. Now we're going to go ahead and look at describing the oxidation reduction reaction. Notice there are notes at the top about your pictures. A picture of your test tube after 30 minutes. This is pretty cool looking picture. I really do recommend it. And then step 7, your paper with your reaction work written on it. Some notes on observations. So these are important in chemistry. If you see a liquid or a solid, what color is it? Either one. Are there bubbles, fizzing, smoke, smells, that kind of thing? Those are all good observations. Clear is not a color. If it's like water, then it's colorless. Note, silver nitrate, it will cause a brown stain if you get on your skin, but it will wear off. It shouldn't cause other damage. So no silver nitrate, that's what you're going to be using right here. And in data table 1, Let me make sure. Yeah, I'm still in student view. Making sure I'm in student view. All right. So in data table 1, you're just going to write down your first observation. So when you put them together, you might not see anything. You can just say nothing happens or something. Or you can say the 2 colors that you started with. Another good thing to do is to take a picture initially of everything, because sometimes it's hard to remember, even if you're writing it down. It's always nice to have that picture. Then you write down, you just let it react for like a minute, and then you write your observations, and then after 30 minutes. While you're waiting the 30 minutes, you can go ahead and do part 2, because it also has a wait. Once you can also go ahead and do this part, because you're going to be writing down CU plus AgNO3, and you should be able to write out what that makes. It should make 2 things, and one of them is going to be combined with the nitrate, and one of them is going to be solo. Let's see. And by the way, this is going to be a copper, like this copper starts off neutral, but it will be a copper 2 when it combines. Sometimes that's unclear. You should be able to see if there's anything spectator-wise. Make sure that the element that oxidized, that should be not the oxidizing agent, but it should be the reducing agent, because the names are switched. And so that's data table 1, and you'll put your photo here. And sometimes you can put both your work and the picture in that one photo. The picture of the test tube at the end. So there's your little a setup, really and truly. This one isn't going to take very long. You're just going to get a little copper out. It's like just little strips of it. And you're just going to put a little bit in the test tube. You're going to put that bottle in, and you're going to wait. That's all it is. Again, you can go ahead. I wouldn't just like do nothing while you wait. I'd go ahead and like write out the reaction, get started on the next part, you know, that kind of stuff. Some notes about the questions. Please put the definitions. For question 1, it asks for you to find these things. Please put them on separate lines. And don't forget that you should describe how this affects the oxidation number. I've said it a few times what oxidation does. The oxidation number should either increase or decrease. And then same with reduction. I mean, and they should not do the same thing. One goes one direction, one goes the other. And also for question 2, put each definition on its own line. And if you're not sure, go back to the material and read about it. You can definitely find the answers there. Question 3, you need to put the new substance. Like, don't put this again. Sometimes students will do that. The new substance. So you're going to have something solid and something that's like not solid. So you're describing what it looks like, and you're going to be describing the like in the reaction it says describe that and identify the chemical formula. So you're identifying the chemical formula of the solid that forms. Remember, you've got the solubility chart to help you if you're not sure. And then here's a reminder about the activity series. You can go back to your notes about this, about most active, least active. So, you know, you basically did a reaction with copper and then silver, and yeah, it was silver nitrate, but you did a reaction with these 2. And the whole idea is if the reaction happened, then it means copper goes on top. But if the reaction didn't happen, it means the silver goes on top. So you're looking at the one that doesn't have a partner, copper, and you see a reaction happening, then it means that copper goes on top. It's more reactive. And then here, these are solids. So this, what you need to do, make sure you write, again, this is copper 2. It's not saying it, they should have. This is silver 1, just so you know. So solid copper 2 sulfide, that's CuS plus silver nitrate, AgNO3, makes. And then this is Cu. Nitrate is a -2 charge. I'm sorry, it's a -1 charge. So sorry. The copper is a +2. So you need 2 -1 charges to balance out your copper. And then silver is a +1 charge, and sulfate is a -2. So you're going to need a 2 by the silver part of it, and you know, in the subscripts. So then after you get that right, then you need to balance that chemical equation. Once you balance it, you can identify the oxidation numbers. Don't forget to do this. And again, if you're not sure, go back to the section about oxidation numbers. And please identify like this is copper, this is a Cu and an S. Each of those should have an oxidation number, and then Ag, the nitrates NO3, the N should have an oxidation number, and so should the O. So you want to write that out. If something is changing, like if one of the oxidation changes, then it is a redox. If nothing changes, like if they all have the exact same oxidation numbers, then it's a non-redox. All right. And notice this is all kind of spelled out right here too. Now the second part. And again, you probably would even have time to set this up before your first 30-minute timer is over. So you're kind of leveraging some of your time with this. You will need some pictures. In this one, you're going to do the well plate after reaction. I recommend taking it before because it's nice to do a comparison. Make sure your signature is on the paper. And you need to write out the handwritten reactions. Also, here's the reaction, write out what you see again. If nothing happens, so if you'll just write NR, that'd be great. Don't rewrite the same original observation. And if you do see changes, you know, write those darker, lighter. You don't have to describe what was there before, just what has changed. This is the well plate, and notice that you can label. You can put your well plate on paper and label it. You don't have to do grid like this. It can be nice though. You won't use all of these little well plate sections. These are for tiny reactions though. So this explains how to use the plastic pipettes if you want to. This is also going to be in the anions, cations, and that'll be done later. All right, I'm going to go on down here. What should you expect? So just FYI, one solid should react in both cases. One solid should react in one case, and one wouldn't react in either case. So this should be your top, your middle, and your bottom. If you aren't sure, you've got the pictures, maybe you can compare. One is not very easy to see. So you might zoom in, you know, with some really good lighting. So this is all you're going to do. You're going to take basically 3 pieces of metal. You're going to take a piece of copper, you're going to take the lead, and then you're going to and then you're going to add liquid to both of them. Notes one thing about the lead here. So this lead, you won't be able to see the reaction very well unless you do this step and you wipe it off. It'll be really, really hard to see. So make sure you do wipe it off. Wipe everything before you do the reaction with it. So notice you have the lead in squares B1 and B2. Notice that you have the little pieces of foil in A1 and A2. And then let me find the other section. And then you're going to have zinc. And so it's called mossy zinc, but honestly, sometimes in the kits, it just shows up as like little strips of zinc metal. And those are going to be put in wells C1 and C2. So you're going to have like a little piece of metal in each of these little wells. There'll be 6 that you're going to be using. And so you'll have 2 of each type of metal in there. And then basically what you're going to do is add liquid to each of them. So that's kind of how I would probably set it up. So in the first one, where you've got the copper pieces in it, you're going to add this to one of them, and then you're going to add this to the other one. And you're going to write down your observations. Then to the 2 that have the lead in it, you're going to add liquids. And you're going to find, let's see, this one. And there's the other one. I skipped past it. Oh, this one. You're going to add this one to that. Then in the last 2, you're going to find that liquid and add it to the zinc, and this liquid and add to the zinc. So basically it's like you got 6 little ones that have little piece of metal in them, and you're just adding liquid to it. And you're going to record your observations before and after in all of these little cases. And again, one should react like in the A. If that's the one that's the most reactive, that should be at the top. Both of these will react. If that is the least reacted, neither of those will react. If it goes in the middle, one of the 2 will react. And again, you're just going to be using these 6, and that's all you're using. And you have to wait to make sure that you can tell. One of them, actually, you probably really will be able to tell pretty fast, in which case you won't even have to wait 30 minutes. But between the other 2, you're going to have to wait to see. You can go ahead and clean up the rest of everything, though, while you're waiting. And you can also answer these questions while you're waiting. So remember the three metals we were saying up here? So you had the mossy zinc, which again, it might just be labeled zinc and it might just look like a piece of zinc. You had the copper, and then you had the lead. So those are the three metals. You need to indicate the oxidation number when they're pure and when they're in a compound. And the pure one's not really a trick question. It's just that like when something's pure and it's not combined with anything, it should not have anything but a zero oxidation number. So hopefully that helps you get the answer on that one. There are some other tips in here about cleaning up. Don't combine your pictures. Oh, if you don't combine your pictures, make sure you paste your two experiment pictures into a file and put in the PDF. Which is an oxidation agent. Remember, reduction, the matching word for that is oxidizing agent. Those both should be describing the same reaction. All right, so they should both be describing the same reaction. And then here's the strongest reducing agent. So one of these answers, and if you're not sure, you might have to go back and look up, one of these answers is going to be the one that reacted both times, and one of them is going to be the one that reacted neither time. And this is, if you're not sure on this, this is in the notes in the first section. And here's your three metals, and I would just, whichever one is the most active, put at the top, like it said, and then just put a line, and then the next, and then the next. So hopefully this helps explain this lab and it's not too confusing. Let me bring this up and stop recording.